So let's start. On August 15, 1977, at 11:16 p.m., a volunteer astronomer named Jerry Amon was reviewing computer printouts at Ohio State University's Big Ear radio telescope. The night was quiet, unremarkable, just another shift scanning the cosmos for patterns in the noise. He was looking at columns of numbers and letters, the kind of data that would put most people to sleep. Random characters representing random cosmic static, 37, 21, 42, the usual chaos of a universe that mostly just hisses at you. Then he saw it, a sequence that made him freeze. 6 characters that shouldn't have been there. 6EQUJ5. He grabbed a red pen and circled them. In the margin he scrawled a single word that would echo through decades of speculation and wonder. Wow. Just wow. What Jerry had stumbled upon was a signal 72 seconds long, coming from the direction of the constellation Sagittarius. It was strong, really strong, 30 times louder than the background noise. And here's the kicker, it was transmitting at 1420 megahertz, which is the natural frequency of hydrogen, the most abundant element in the universe. Scientists had long theorized that if anyone out there wanted to say hello, they'd use this frequency. It's like the cosmic phone number everyone would know. The WOW signal, as it came to be called, has never been detected again, not once. The Big Ear telescope kept listening. Other observatories pointed their dishes at the same spot in the sky, and nothing. Silence. Some scientists suggested it could have been a passing comet releasing hydrogen, except comets weren't known to be in that area at that time. Others thought maybe it was a satellite reflection, but the signal's characteristics didn't match any known satellite. And here's what makes it so eerie. The signal was narrow band, which means it was focused, deliberate, not the kind of broad-spectrum noise that natural phenomena usually produce. The bandwidth was incredibly tight, almost impossibly so for something natural. It's the kind of precision you'd expect from an engineered transmitter, not from a random cosmic event drifting through space. The signal rose in intensity, peaked, and then faded away, following a pattern that matched almost perfectly what you'd see if the source was rotating into and then out of view. To put it in perspective, imagine someone calling your phone once, saying something that sounded almost like words but not quite, and then vanishing forever. You'd spend the rest of your life wondering if it was a wrong number, a prank, or something else entirely. That's what the WOW signal represents, a cosmic question mark that we can't erase. Jerry Amon himself remained cautiously skeptical until his death, never claiming it was aliens, but never ruling it out either. He knew what he saw, and he knew it was extraordinary. The signal came. It spoke in a language we almost understood, and then it left us wondering. Decades later, we're still wondering. The silence that followed has been deafening. Every anniversary of the detection brings renewed interest, renewed hope that maybe this year we'll hear it again. But the universe keeps its secrets well. But that's nothing compared to what astronomers discovered much later. Fast forward to April 2019. Scientists at the Parkes Observatory in Australia were analyzing data when they noticed something strange. A signal coming from the direction of Proxima Centauri, the closest star system to Earth, just over 4 light-years away. They called it BLC-1, short for Breakthrough Listen Candidate 1, and this wasn't just random noise. This signal had a frequency drift, meaning it was shifting in a way that suggested it came from something moving, like a planet rotating or a transmitter in motion. Natural sources don't usually do that. They tend to stay put, frequency-wise. Here's where it gets weird. The signal appeared multiple times between April and May 2019, always in the same narrow frequency range, around 982 megahertz. It would show up, last for a few hours, and then disappear. What makes this even stranger is that Proxima Centauri has a planet, Proxima b, sitting right in the habitable zone where liquid water could exist. Scientists had already been eyeing this planet as a potential candidate for life, and now suddenly there's a radio signal coming from that direction. Coincidence? Maybe. But it gave people chills. The timing seemed almost too perfect. It was as if someone knew we were watching and decided to give us something to think about, something to obsess over for decades to come. The team analyzing BLC-1 spent months ruling out terrestrial interference. They checked satellites, aircraft, cell towers, anything that could produce a signal in that frequency range. And for a while, BLC-1 held up. It seemed genuine, or at least genuinely unexplained. Then in October 2021, after exhaustive analysis, researchers concluded it was likely interference from human technology, possibly a malfunctioning device or an unknown satellite. But here's the thing. Even the scientists who debunked it admitted the signal had unusual characteristics that made it hard to pin down definitively. Some aspects of it still don't fit perfectly into the interference explanation. The frequency drift pattern was odd, almost too deliberate for random noise. What this means is that we're getting better at detecting faint signals from space, but we're also surrounded by so much of our own electromagnetic noise that separating the real deal from the fake has become incredibly difficult. Every phone, every satellite, every piece of electronics is screaming into the void, creating a fog of signals that we have to sift through. It's like trying to hear a whisper in a room full of people shouting, and the question becomes, how many real signals have we missed because they got buried in the noise? How many times has the universe tried to reach out, only for us to brush it off as interference? We're essentially deaf to anything that doesn't scream at us. To understand why these signals are so compelling, you need to know what scientists are actually looking for. When we scan the cosmos for signs of intelligence, we're not expecting aliens to speak English or send us a map. We're looking for patterns, repetition, something that stands out from the randomness of nature. Natural radio sources like pulsars and quasars emit signals, but they're usually broad spectrum, messy, chaotic. An artificial signal would be narrowband, focused like a laser compared to a light bulb. It would have structure, maybe even modulation, the way our radio stations carry music and voices. Something that screams intentionality rather than accident. But here's the creepy part. Sometimes we find signals that almost fit the criteria but not quite. They're tantalizing, sitting right on the edge of what could be natural and what could be designed. In 2007, astronomers detected the first fast radio burst, or FRB, a sudden blast of radio energy that lasted just a few milliseconds but released as much energy as the sun emits in an entire day. At first, people thought it might be a glitch in the equipment. Then they found more. Hundreds of them coming from all over the universe, some repeating, some not. Each one a puzzle that doesn't quite fit together. One FRB in particular, FRB 121102, caught everyone's attention because it repeated. Most FRBs are one and done. But this one kept firing off bursts at irregular intervals, and they traced it back to a dwarf galaxy, 3 billion light-years away. Scientists have proposed all kinds of explanations: neutron stars, black holes, cosmic strings, even the possibility of alien technology. The thing is, none of the explanations fit perfectly. Each theory accounts for some characteristics, but fails to explain others. It's like having a puzzle where the pieces are close, but not exact. The energy output is staggering, almost violent in its intensity. Whatever's causing these bursts is incredibly powerful. What makes FRBs so mysterious is their sheer power and brevity. To generate that much energy in such a short time requires something extreme, something violent or incredibly advanced. If it's natural, it's a phenomenon we've never fully understood. If it's artificial, well, that would suggest a level of technology far beyond our own. And the fact that some FRBs repeat while others don't adds another layer of strangeness. Why would some sources keep broadcasting while others go silent? Is it a matter of geometry, like a lighthouse beam that only sweeps past us occasionally? Or is it something else entirely? Something with purpose behind it, something deliberate? Let that sink in for a moment. We're detecting signals from across the universe that we can't explain. Signals with properties that challenge our understanding of physics and technology. Some last seconds, some last milliseconds, and some never repeat. Each one is a mystery wrapped in radio waves, a question we can't yet answer. And every time we think we figured one out, another one appears that doesn't fit the pattern. The universe is basically littered with cosmic question marks, and we're just starting to notice them. Every detection brings more questions than answers, more confusion than clarity. The most unsettling part isn't that we don't know what these signals are, it's that we might be living in a universe full of transmissions we're simply not equipped to understand. Maybe intelligence doesn't always announce itself the way we expect. Maybe the signals we're picking up are the equivalent of alien elevator music, background noise to civilizations so advanced that they don't even realize we're listening. Or maybe, just maybe, someone out there is trying to reach us, and we're too busy arguing about whether it's a comet or a satellite to notice. We might be missing the message because we're looking for the wrong language, listening for the wrong sounds. Because in space, when something calls out to you, there's no guarantee it will call again. Speaking of signals that mess with our heads, there's a whole category of detections that scientists thought were alien transmissions until they realized something much weirder was happening. And what makes these cases fascinating isn't just that we were wrong, it's how close we came to announcing to the world that we'd found proof of extraterrestrial intelligence, only to discover the truth was somehow stranger than we imagined. In 1967, a graduate student named Jocelyn Bell Burnell was analyzing radio data from a new telescope at Cambridge University when she noticed something peculiar. A series of pulses, incredibly regular, arriving exactly every 13373 seconds. Not approximately. Exactly. Natural phenomena aren't supposed to be that precise. The pulses were so consistent that the team nicknamed the source LGM-1, which stood for Little Green Men 1. They actually considered the possibility that this was an artificial beacon from an alien civilization. For weeks, they kept it quiet, trying to figure out if they were about to change human history. The tension in that lab must have been incredible. Then they found another one, and another. 4 different sources, all pulsing with the same kind of mechanical regularity, but at different intervals. If these were alien transmissions, that meant multiple civilizations were broadcasting in our direction, which seemed unlikely. The team realized they were looking at something natural, but previously unknown. Pulsars, rotating neutron stars with magnetic fields so intense they beam radio waves into space, like cosmic lighthouses. When the beam sweeps past Earth, we detect a pulse. Jocelyn Bell had discovered an entirely new class of astronomical object, and she did it because she was looking for aliens. Irony at its finest. The discovery that won her a place in history came from the assumption that aliens might be calling, even though aliens had nothing to do with it. Here's what's interesting about that. The LGM-1 signal had every characteristic that SETI, the Search for Extraterrestrial Intelligence, looks for in an artificial transmission. Regular intervals, narrow frequency, persistent over time. It checked all the boxes except one. It was natural, which raises an uncomfortable question. How do we know the signals we're detecting now aren't just phenomena we haven't discovered yet? How many times have we dismissed something as impossible only to find out later it was just nature being weird? The universe has a talent for producing patterns that look designed even when they're not. And that's the trap we keep falling into, mistaking nature's creativity for intelligence. But then there are signals that refuse to fit into neat categories. Take the case of the peritons. In the early 2000s, radio telescopes in Australia kept picking up these strange bursts that lasted a few milliseconds and showed up at random times. They had similar characteristics to fast radio bursts, but something about them felt off. They only appeared during business hours, which seemed suspicious. Natural cosmic phenomena don't care about our work schedules. For years, researchers assumed these were some kind of terrestrial interference, but they couldn't figure out the source. They tested everything, checked every piece of equipment, eliminated every possibility they could think of. The answer, when it finally came, was both hilarious and frustrating. Microwave ovens. Staff members at the observatory were opening the microwave door before the timer finished, which caused the magnetron inside to emit a burst of microwave radiation that the telescope picked up. Peritons weren't cosmic mysteries, they were lunch breaks. But here's the kicker. If scientists hadn't been so thorough, if they'd just assumed these were real FRBs and moved on, we'd still think there was a population of mysterious signals coming from Earth's atmosphere. The Periton case taught astronomers an important lesson. When hunting for aliens, sometimes the biggest obstacle is ourselves. Our own technology creates more noise than we realize, drowning out potential signals. That brings us to SHGB 22 Plusm Spuntinae, one of the most controversial signals SETI has ever detected. In 2004, researchers using the Arecibo telescope in Puerto Rico found a signal that appeared 3 times in the same frequency range, about 1420 megahertz, the hydrogen line we talked about earlier. The signal was weak, right at the edge of detectability, but it kept showing up in the same spot between the constellations Pisces and Aries. What made it unusual was that it was coming from a point in the sky with no known stars, no galaxies, nothing that could obviously produce such a signal. Just empty space, or what looked like empty space to our instruments. The SETI Home project, which uses distributed computing to analyze radio telescope data, flagged SHG B02+14a as a candidate for extraterrestrial intelligence. For a while it was taken seriously. The frequency was right, the location was consistent, and the signal appeared multiple times. But then it stopped. Researchers tried to detect it again, pointing bigger telescopes at the same coordinates, and found nothing. Some scientists argued it was just a random glitch, a statistical fluke amplified by wishful thinking. Others weren't so sure. The signal's characteristics didn't match typical interference patterns, and its location in an empty region of space made it harder to explain as a terrestrial source. The debate continues to this day, with believers on both sides refusing to concede. It's become one of SETI's most enduring mysteries, a signal that won't let go of our imagination. To this day, SHG B02+14a remains unresolved. It's not officially classified as an alien signal, but it's also not definitively explained. It exists in that gray zone where science admits it doesn't have all the answers. And that's what makes signals like this so compelling. They're not proof of anything, but they're not nothing either. They're reminders that the universe still has secrets we haven't figured out, questions we can't answer with our current understanding. Maybe it was interference, maybe it was a distant satellite, or maybe it was something else, a transmission from a civilization that broadcast once and then went quiet, leaving us with only an echo that haunts radio astronomers to this day, a ghost in the data. What's even more frustrating is that we know we're missing signals all the time. Our telescopes can only observe a tiny fraction of the sky at any given moment, and radio signals are fleeting. If a civilization beamed a message in our direction for just a few seconds, the odds of us pointing a telescope at the right spot at the right time are astronomically low. It's like standing in a field during a rainstorm and trying to catch a specific drop in a cup. You might get lucky, but most of the time you'll miss it entirely. And unlike raindrops, alien signals don't come with a second chance. If we're not listening when they transmit, we'll never know they were there. The universe doesn't repeat itself for our convenience. Then there's the problem of recognition. Even if we detect a signal, how do we know what we're looking at? Pulsars seemed artificial until we understood them. Fast radio bursts still seem half artificial because we don't fully understand them. And that's assuming aliens would use radio waves in the first place. Maybe advanced civilizations have moved on to neutrinos, or gravitational waves, or some form of communication we haven't even imagined yet. Maybe they've been shouting at us in a language we don't have the technology to hear, and we're sitting here wondering why the universe is so quiet. It's humbling and terrifying at the same time, realizing how limited our perception truly is. Consider this. In 1977, NASA launched the Voyager probes with golden records attached, containing sounds and images from Earth, music, greetings in multiple languages, pictures of humans and animals. The idea was that if aliens ever found the probes, they'd learn something about us. But here's the thing. Those records assume aliens have eyes and ears. They assume aliens understand the concept of images and sound waves. They assume a whole lot about what intelligence looks like. What if we're doing the same thing with our SETI searches? What if we're looking for signals that match our idea of communication, while missing transmissions that don't fit our expectations? We could be surrounded by alien messages and never realize it. That's the terrifying beauty of unexplained signals. Each one forces us to confront the limits of our knowledge. Each one asks, what if? What if the WOW signal wasn't a comet? What if BLC-1 wasn't interference? What if FRB 12192 is someone's version of a lighthouse, guiding travelers through the dark? We don't know, and that uncertainty is both maddening and exhilarating. It keeps astronomers up at night, scanning the same patch of sky for hours, hoping to catch something we've never seen before. Hoping that this time the signal will repeat, that this time we'll understand it, that this time we'll be ready for whatever answer the universe decides to give us. The most honest answer science can give is this: we've found signals we can't explain, patterns we can't replicate, transmissions that don't fit our models. Some of them probably have mundane explanations we haven't thought of yet, but some of them might not, and until we can prove it one way or the other, we're stuck in this limbo between skepticism and wonder, between dismissing the unknown and chasing it across billions of light years. Because the alternative, assuming we've already found everything there is to find, is far more depressing than the possibility that the universe still has mysteries waiting for us. The real question isn't whether we'll find proof of aliens, it's whether we'll recognize it when we do. And it gets weirder, because while we've been scanning the cosmos for radio signals, something else has been happening that scientists didn't expect. Objects are showing up in our solar system that don't behave the way they should, and some of them might be broadcasting in ways we're only beginning to detect. In October 2017, astronomers at the Pan-STARRS telescope in Hawaii spotted something moving through our solar system at an unusual angle. They named it Oumuamua, which means scout or messenger in Hawaiian. At first they thought it was a comet or an asteroid, just another piece of space rock passing through. But the more they observed it, the stranger it got. Oumuamua was tumbling through space in a chaotic rotation, accelerating in ways that couldn't be explained by gravity alone. It was shaped like a cigar, roughly 10 times longer than it was wide, unlike any asteroid we'd ever seen. And when they pointed radio telescopes at it to check for signals, they found nothing. But the silence itself was suspicious. Dead silence from something so strange. Here's what made scientists do a double-take. Oumuamua accelerated as it moved away from the sun, but it didn't have a visible tail, which meant it wasn't outgassing like a comet. Some force was pushing it, and the most likely explanation was solar radiation pressure acting on a very thin, flat object, like a sail. Harvard astronomer Avi Loeb suggested that Oumuamua could be a light sail, a piece of technology designed to harness sunlight for propulsion, the kind of thing an advanced civilization might use for interstellar travel. Not everyone agreed with him, and the scientific community debated whether he was being visionary or reckless. But the fact remains, Oumuamua didn't fit the profile of any natural object we know. It was an anomaly in every sense of the word. And here's the truly unsettling part. Oumuamua wasn't emitting signals we could detect, but that doesn't mean it wasn't transmitting. If it was a probe, it could be using communication methods we don't have the tools to intercept. Laser pulses, for example, are nearly impossible to detect unless you're looking directly at the source. Or maybe it was using quantum entanglement, or neutrinos, or something we haven't discovered yet. The absence of a signal doesn't prove anything except that we weren't listening the right way. Oumuamua came, it behaved strangely, and it left, vanishing back into the void before we could study it properly. If it was a probe, we missed our chance. If it wasn't, we just witnessed the universe throw us one of its weirdest curveballs. Either way, we're left wondering. But what if unexplained signals aren't just about listening? What if they're also about timing? In December 2020, the Arecibo telescope collapsed. The massive radio dish that had been scanning the skies for decades, the same telescope that detected the WOW signal and countless other mysteries, was destroyed. And with it, we lost one of our most powerful tools for detecting faint signals from space. Some researchers believe we've entered a critical period, where our ability to listen is shrinking, just as the number of detections should be increasing. We're building new telescopes like the Square Kilometre Array in South Africa and Australia, but there's a gap, a window where we're blind to signals we should be catching. A dangerous gap in our awareness, a blind spot that could last for years before the next generation of equipment comes online. Think about that. Right now, at this very moment, there could be a civilization trying to contact us, broadcasting at a frequency we've temporarily stopped monitoring. Or maybe they already tried. Years ago, and we were looking the other way. Time matters in this search. Signals fade, sources move, and opportunities close. The universe doesn't wait for us to be ready. It keeps transmitting, keeps broadcasting its mysteries, and if we're not there to listen, those mysteries disappear into the noise forever. The scary part is we'll never know what we missed. We'll never know how many times someone called and we weren't home. That's the most frustrating part of the whole endeavor. The ghosts of missed connections haunt every astronomer. And then there's the question of intention. Even if we detect an unambiguous alien signal tomorrow, what does it mean? Is it a greeting, a warning, a distress call, or is it just background radiation from a civilization that doesn't even know we exist? SETI assumes that any sufficiently advanced civilization would want to communicate, but that's a very human assumption. Maybe intelligence develops in ways that don't value communication the way we do. Maybe some civilizations go silent on purpose, hiding from the universe because they know something we don't. The dark forest theory, proposed by science fiction author Liu Cixin, suggests that the cosmos is full of civilizations staying quiet because broadcasting your location is dangerous. If that's true, every unexplained signal we detect could be a mistake, a leak from someone who didn't mean to be found. And we're sitting here trying to decode it, completely unaware of the risk. There's also the possibility that we're already receiving signals, but interpreting them wrong. In 2018, researchers discovered that some fast radio bursts follow patterns, repeating on cycles that suggest they're not entirely random. FRB 180916, for instance, operates on a 16-day cycle, active for 4 days and then silent for 12. That kind of periodicity is unusual for natural phenomena. It could be the rotation of a neutron star, or it could be something else. Something scheduled. If you wanted to send a message across the galaxy, you'd probably repeat it on a predictable schedule to increase the chances of someone detecting it. But proving intention is nearly impossible without more context. We see the pattern, we recognize it's strange, and that's where the trail goes cold. We can't go further without more data, without more pieces of the puzzle. What's even more unsettling is the realization that most of the universe is invisible to us. We can only detect electromagnetic radiation, a narrow slice of the spectrum that includes radio waves, visible light, and a few other bands. But the universe is full of things we can't see. Dark matter, dark energy, phenomena that don't interact with light in ways we understand. If aliens use communication methods based on physics we haven't discovered, we'd be completely oblivious. It would be like trying to watch a movie without realizing the screen is there. We'd hear the sound, maybe catch a flicker of movement, but we'd never see the full picture. That's a terrifying thought, that we could be surrounded by messages and never know it, swimming in a sea of information we can't perceive, like a blind person in a library full of books written in invisible ink. This is the humbling part of the search. Every unexplained signal is a reminder that we're novices in a cosmos that's been around for 13 billion years. We've been using radio telescopes for less than a century. We've been seriously searching for alien intelligence for maybe 50 years. In cosmic terms, that's a blink. We're infants fumbling with a phone we barely understand, hoping someone on the other end hears us. And when we do catch something, a burst, a pulse, a pattern that doesn't make sense, we're left guessing. Was it them? Was it us? Or was it the universe doing something strange and beautiful that we'll spend the next 100 years trying to explain? The questions pile up faster than the answers. We're drowning in mystery, suffocating under the weight of questions that have no answers, at least not yet. The unknown presses down on us, demanding acknowledgement, demanding that we keep searching even when the search seems futile. Maybe the most profound mystery isn't whether aliens exist. It's whether we're capable of recognizing them if they do. Maybe they've been here all along, transmitting in frequencies we haven't thought to check, using methods we haven't invented, speaking a language that doesn't translate into anything we'd call communication. Maybe the wow signal was the universe's way of saying hello, and we said wow back, but neither of us understood what the other meant. Or maybe every unexplained signal is just noise, random fluctuations in a chaotic universe that we're desperate to find meaning in because the alternative, that we're alone, is too much to bear. That loneliness drives us to keep searching, keeps us scanning the skies night after night. But here's the thing, even if every signal we've ever detected turns out to be natural, even if the WOW signal was a comet and BLC-1 was interference and FRBs are just neutron stars doing neutron star things, the search itself matters. because it forces us to look up. It makes us question. It reminds us that the universe is bigger and stranger than we can imagine, and that somewhere in all that vastness, there might be someone else looking up too, wondering the same things. And if we ever do find an answer, if we ever detect a signal that can't be explained away, that can't be dismissed, it won't just change science, it will change everything. Our place in the universe, our understanding of life, our very identity as a species, will transform overnight. Because in space, when something calls out to you, and you finally understand what it's saying, there's no going back to the way things were. The moment we confirm we're not alone, we'll never be the same. And maybe that's what all these unexplained signals are preparing us for. Not a message from aliens, but a message from the universe itself, telling us we're ready to step into a larger world. One where the questions are as infinite as the stars, and the answers are waiting for us to become wise enough to understand them. The signals will keep coming, whether we're ready or not. The universe doesn't ask permission to be mysterious, doesn't wait for us to catch up. It simply is, vast and strange and full of things we've barely begun to comprehend.